Okay, we are starting now. Hello, everyone. A very good afternoon to all of you. I am Minakshi, welcoming you all on behalf of Solar Quarter and First View Group to the first day of Thailand Solar Week 2022. I hope you all had a great time networking with your peers today. Now it's time to start our conference. But before that, I'd like to take this opportunity to thank our sponsors, Platinum Partners Could Be and Yokogawa Engineering Asia, for extending their immense support to organize this event. I would now request my team to play the sponsor videos.
Yokogawa is having an impact in many ways, both in industry and everyday life. For example, we help to secure the supply of safe water, an essential lifeline for all. Through the provision of advanced solutions for the recycling and effective use of water resources, Yokogawa has contributed to the stable supply of water. The same is true for food and pharmaceuticals. In this era of digital transformation, also known as DX, Yokogawa is making a difference in many more ways, from the quality control of materials and increase of productivity to the building of supply chains. To promote health and well-being, we provide solutions for the research and development of new drugs and the production of high-quality pharmaceuticals. Amidst a growing global demand for energy, concern about climate change is driving an energy transition. In the era of DX, Yokogawa is working with its customers in the energy industry to create new value. For the production of different types of energy resources, we provide our customers the solutions they need to reduce their environmental impact and maximize efficiency. In new energy fields, we build stable energy supply systems that factor in predictions of supply and demand and support new business model transition. In the era of DX, Yokogawa is working with its customers in the energy industry to create new value. For the production of different types of energy resources, we provide our customers the solutions they need to reduce their environmental impact and maximize efficiency. In new energy fields, we build stable energy supply systems that factor in predictions of supply and demand and support new business models. Through the operation of energy management systems, Yokogawa is helping to achieve a sustainable society. Modern society depends on a countless variety of materials. Industries that produce these materials are facing many challenges, including recycling and the production of new, environmentally friendly materials. We closely examine manufacturing processes and leverage the potential of DX in development and production to meet the unprecedented demand for materials with new functions and characteristics that will contribute to decarbonization and be easy to recycle. By engaging in co-creation with its customers, Yokogawa is able to come up with new solutions for the handling of materials. With the aim of achieving a circular society, we co-create cutting-edge biomass-based materials and provide the necessary manufacturing technologies. Yokogawa provides a great variety of solutions, such as the OPREX lineup, that create value for its customers and point the way to a sustainable society. Through the use of machine learning to optimize models, we integrate the management of an ever more diverse range of processes all over the world. By accurately monitoring, analyzing, and predicting process conditions, we are able to respond quickly and flexibly to changes and maximize the value that is created. We ensure stable, long-term operations by constantly monitoring facilities over their entire life cycle. Having contributed to the evolution of automation, we are now making stepwise progress in the direction of smart manufacturing. Using AI, robotics, and other technologies, we are supporting a transition from automation to autonomy that will transform society as we know it. Through co creation with our customers and partners, we will strive for the realization of a system of systems concept that will set society on a new path. Systems that power our infrastructure, companies, and homes will be directly connected and interact with each other to autonomously optimize society as a whole. Yokogawa will continue to build systems that link companies and industries all over the world and provide added value by serving as a node for the sharing of information. Utilizing our ability to measure and connect, we fulfill our responsibilities for the future of our planet. Yokogawa will continue in its endeavors to create a future where people and the Earth can coexist in symbiotic harmony. Yokogawa, co-innovating tomorrow.
Thank you, team, for playing the videos. Now, let me quickly take you through the agenda for today. We will be having two presentations and a panel session that will be focused on utility solar sector, large scale solar growth opportunities, and technology outlook. So, without any delay, let's begin our first session. This session will be started with a knowledge presentation by Mr. Nonthi Ched Sangwan from Mott McDonald. I welcome Mr. Nonthi on screen.
Sure. Hi, thank you very much. So please allow me to share the screen as well. Wait for a second. Okay. All right. I hope everyone can see the screen I'm sharing properly. Otherwise, please text in the chat box to let me know. So good afternoon again, everyone. Just to quickly introduce myself, Nanti, Energy Sector Leader of Thailand and Solar PV Development Manager of Southeast Asia. I'm coming from Mott McDonald, based in Thailand. So this is a good opportunity for me to discuss with everyone in the theme of the growth opportunity of the solar PV in Thailand. And from now on till the next around 15 to 20 minutes, I will be discussing in more detail on the context around the opportunities, the key considerations, and any lesson learned in relation to the solar PV technologies and market in Thailand. Here is the agenda. I will not spend much time, but only to elaborate quickly who we are, especially in the solar sector. To set the theme, I will give an really overview of where we are on the Southeast Asia solar PV market. The aim is to give some flavors of how is the current cumulative capacity of solar PV market development in our regions, not just only in Thailand, but let's say in Southeast Asia. And then the rest of the sessions, we will put more focus on the discussion what options and opportunities do we have and what we expect to see now and in the near futures for the solar PV solutions in Thailand. All right, as Mott McDonald, we are global technical and engineering management consultancy. We operating in 180 offices in 180 countries. We have the staff around 18,000 staff as of now and spread around the world. In Asia Pacific, if you see from the right hand side, we are very active. We have staff over 1,300 people in the regions. We are providing the service in multi sectors. Not just only energy, but other sector. But if we talk about the renewable energies, of course, we cover the full range of the service for renewable energy technologies, not just the solar. Right hand side is the conservative figures of the key solar experience in Thailand, and we have involved in the solar PV market in Thailand over decades from greenfield projects, and now most of the projects under operations at the moment. All right, jumps to the main topics. This slide presents the overview of where we are in Thailand and also in our neighboring countries in Southeast Asia in terms of the cumulative capacity. The upper graph presents the cumulative capacity of renewable energies in 20 up to 2021 in the key selected countries and cumulative as of the Southeast Asia, whereas the bottom graph shows the cumulative capacity of the solar PV installations in the chronicle orders from the past to up to 2021 for the key countries as well. Some key takeaways from this slide is that for all the countries, the dominant renewable energy technologies majorly contribute to that is still hydropower. There is an exceptional case for Thailand, which is the only country that the renewable energy technologies are diversified equally amongst hydropower, wind, solar, and biogas. A small note for Vietnam, I think everyone here are aware of Vietnam renewable energy market just recently booms in the last over the last 2 years, especially for the solar. The significant increase in Vietnam mainly due to the previously announced feed-in tariff scheme in the country. How about Thailand? Thailand have the cumulative installed capacity around, let's say, roughly 12 gigawatts. Hydropower take around 30%, around 3.7 gigawatt, wind around 1.5 gigawatt, and solar around 3 gigawatt. The rest will be biogas and energy from the west. Specific for solar, the market in Thailand is already matured in terms of the technology and commercial considerations. We have seen a number of large-scale ground mount solar PV projects under operations for many years now and in various locations across the country. And this is considered as a proven track record, right? Now, if we look back to the current operating solar PV projects in Thailand, taking into account the technical barriers and challenges due to the technology itself, considering the newly announced feed-in tariff scheme as of this year, and also the advancements of the technology development globally, there will be a questions around what we would expect to see and gonna become to be the new norms of the solar PV sector in Thailand. And that's come to the point of, as you can see from this slide, we have pinned out here three key aspects that will play the important factors driving the directions of the solar PV applications in our regions. I mean, actually, it's not just only in Thailand, but also applicable in Asia Pacific as well. These three key promising options include the floating solar PV applications, the introductions and integrations of the energy storage systems, and the last one is the advancements in the PV module technologies. Allow me to go one by one. This slide presents the highlight on some key iconic floating solar PV projects that we also involved in these projects and is worth considering. What you can see from this slide is that if you look back over the last 10 years, the, first of the commercial scale floating solar PV projects at that time, we can see is really small scale, 3.8 megawatt in 2013. But now, taking into account the maturity in the technologies development, this open the opportunities for the plant designers and also for the developers to build larger scale floating solar PV projects and even in more extreme environments. So when we talk about the floating solar now, we are not talking about just a megawatt, 2 or 3 megawatt scale, but we are talking in the level of 100 megawatt scale or sometimes gigawatt scale floating solar PV projects. Um, I can say that the floating solar concept is not entirely new. We have witnessed a number of large-scale projects successfully energize electricity to the grid. So, for example, around 2019, we involved in 181 megawatt floating solar PV projects in Taiwan, which is one of the largest projects financed floating solar PV, which is developed over the seawater in the intertidal area. We are also talking about 370 megawatt floating solar PV in Pakistan's over the hydropower co-located at the same locations. That is a good example of the large scale floating solar PV projects. And the same we would expect to see in the near future in Thailand. Still with the floating solar PV themes, I mean, this slide summarize the list of key considerations when planning to develop the floating solar PV projects. These factors can be the sensitive areas affecting the feasibility and the reliability of the floating projects. For example, when developing the floating solar PV projects, we have to take into considerations additional aspect apart from what you typically look for the conventional ground mount projects. Like you have to take more serious on the extreme wind speed and wind load. You have to take into account the maximum and height of the waves, the variations in the water level and the water current, and of course the key sensitive areas like anchoring and mooring designs against extreme load and fatigue life. Those are the key considerations that as a developers, as the financiers to the projects, you will have to come across. And from our experience so far, I mean, on the right hand side, we summarize a couple of broad industry challenges at the moment. I mean, this would include like the lack of matured or standardized approach or standard that are designed 100% for the floating. There is no international standard adopting for the or developing for the floating solar PV projects at the moment, and that is some of the key challenge that the designer have to be careful when design the flow system. There is also a question around the uncertainty of the long-term reliability of the key components, complexity in the technical design, and of course the lack of robust track record. Even though, as I mentioned in the previous slide, I mean, the we have starting to see now a number of large scale floating solar PV projects achieve COD and and now moving to the operations phase. But if we compare with the conventional ground mount projects, I mean, we have we have less proven track record on the floating solar side, and that will take some time for key stakeholders, for each parties to be comfortable with. In terms of the plant performance or energy yield consideration for the floating projects, this slide here summarizes a couple of key aspects which I will not go into detail. But what I would like to say among these key considerations, there is one, let's say, the uncertain area or the gray area that will be difficult to quantify or deal with, which is item number three, the water cooling effect. And not carefully considering this may mislead the energy yield prediction and sometimes can be one of the key uncertain area in the when we are considering the project's finance, or sometimes the financiers or the lenders will have the questions around whether the assumptions of the energy yield taking into account the cooling effect is accurate or not, and that's become the questions. The reasons behind this uncertain area is that the water cooling effect is very strongly depends on not just the float type, but also it's really projects and location specific, depends on the wind speed, depend on the ambient temperatures. If you look into this table, again I will not go into technical detail, but you will see a number of a too many numbers in this table. But what I would like to message here is that there are a number of floating solar PV test beds initiated around the world with the aim to assess what should be the water cooling effect that the developers or financiers can expect for that floating solar PV projects, right? And among the studies, we present in this table the summary of water cooling effect from two credible studies, one from CELES in Singapore and another from TNO in Netherlands. The conclusion is that you can see a broad range of the water cooling effect. This number, the higher the numbers, the better the water cooling effect. But as you can see, but even though those two studies suggest the same way, same directions of the water cooling effect, but the numbers can still very broad, right? So this emphasize the criticality of understanding the site-specific wind speed through the on-site measurements for an accurate understanding of the water cooling effect, given the limited research information so far available. And that is some point that people tend to overlook, and sometimes it can mislead and can can result in, unnecessarily kill the projects as well sometimes. This second factors, we are moving from the floating solar to the how how the solar PV market can be accelerated with the energy storage systems. So energy storage system, or or let's say in this context, battery energy storage system or BESS, this will help the solar PV plant break through some of the key challenges, mostly around the area of matching between the generation of the solar PV plant and on the demand side, or reducing the intermittent issues in the grid network. Those are the key main benefit of battery energy storage systems. I mean, for example, if we are looking at our neighboring countries like in Indonesia, for example, I had a conference a couple of months ago. We were talking about the concept that battery energy storage system is one of the key driver in accelerating the electromobility or e-mobility, um, the definition cover the electric vehicle business or market. And this will help energy storage system will help accelerating the solar PV market as well. Just to give you an idea, for example, if we combine the energy storage system together with the solar PV applications, that can be introduced um, to integrate with the electric vehicle charging stations that can be deployed in the main cities of Indonesia, and 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 that is one of another side benefits of the energy storage system. Um, this slide summarize some case studies of how battery energy storage system will be integrated and used in the solar PV applications in our neighboring countries, not in Thailand. The top one, the first is in case of Japan, the aim of I mean, in Japan, there is an aim to increase the renewable energies portions into the generation size, especially in the northern area of Japan, like in Hokkaido. And so that, to back through the potential grid intermittent issues due to the high portions of renewable energies, the BESS system with the RAM rate control applications will be equipped, installed together with the renewable energy plants with the aim to smoothen the power export, or let's say limit the fluctuation level of the power export to the grid within the certain criteria. Like in case of the northern area of Japan, the fluctuation of power output shall not be higher than 1% of the plant capacity within 1 minute, and that's come to the role of the battery energy storage system. The lower ones, the best load generation in the Philippines. This second example is for the developers who aims to design the solar PV plant with a large-scale energy storage system with the aim to export the power at the constant figure 24 hours to the grid, and that will definitely require the battery energy storage system. Um, this slide shows this slide shows some of the key considerations when we are talking about hybrid between solar PV and energy storage systems. For example, the developers may think of what source of solar resource we could use as the starting point of the hybrid system design. The answer is that this solely depends on the purpose or depends on the applications of energy storage system, right? If we are talking about the previous example of the RAM rate control applications, you may need the reliable solar resource of like at high resolution, at 1 minute resolutions. You may have to develop the on-site irradiation measurement campaign to capture the realistic fluctuation profile in the irradiation and use that as a best case in deciding the battery size. But if we are talking about like in case of this year renewable energy feed-in type scheme in Thailand, this might only require an understanding of the solar resource fluctuation in just hourly or daily resolution that may be already sufficient. So that really depends on the application of energy storage, which will determine which solar resource and at which resolution you would like to look at. The next aspect is very interesting, which show in this slide. The plant designer may want to focus on specific year of historical irradiation and use that as the reference to size the battery. So the questions will be which period or how much extreme in irradiation condition the designer should pick up and use as the reference when decide the battery size, right? For example, if you pick up very extreme year, really low sun condition or significant dynamics in irradiation level and use that time frame to decide the battery size, then of course that it will end up that your battery size will be really large and it will be able to comply all the regulations. But on the economics side, on the financial returns, your projects may not be that feasible, right? Because you tend to oversize the battery size and 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 actually the extreme weather condition may happen just a very small period of time over the next 20 years. So this is something, I mean, the plant designer have to trade off between the pros and cons of oversizing of the battery or undersizing of the battery as well. Last topics, which is just only one slide. This is the last piece of the jigsaw in this presentation, which is the advancements of the PV module technologies. I mean, over the past few years, we can say that the PV module technology is growing really fast, and we now experiencing, everyone here knows, PERC, the PERCs module technologies with high efficiencies. This is the default technologies for over the past few years and even until now. We also start to see the bifacial modules price to be becoming more competitive now with the monofacial PV modules. And even now, I mean, we also witness a number of projects, a number of developers tends to use bifacial modules by default, even though the plant design may not be suitable for the bifacials. But given the price of the bifacial is becoming sufficiently low, and therefore bifacials modules will going to replace the monofacials for some of the projects. In some other regions, like in um, let's say like in Africa, we have seen a classic combination of the bifacial PV modules with the tracker system, which is a great example how to boost the efficiency of the bifacial modules, right? Because if you install the bifacial modules over the tracker system, your rear side of the PV modules will receive higher irradiation and can generate more rear side energy from the PV modules. As of today, a number of manufacturers start launching their modules using the TopCon's technologies. TopCons, I think some of you already heard of this TopCon, the ternal oxide passivate contact modules, which is the modules that introduce one additional layers into the modules with the aim to increase the efficiencies of the PV modules. And it is the N-type PV modules which without any concerns on the some of the LETID loss as you may experience in the PERC technologies. And the international market believe that, I mean, the top cons technologies will coming to replace the PERC technologies very soon. All right, I think that's all from my side for this session, and we can talk more in the panelist discussion. Thank you.
Thank you very much for the insightful presentation. Let us proceed with our sponsor presentation by Mr. Andy Miller from Size Energy Solutions, a Yokogawa company.
All right, so I'm just going to share my screen here. And hopefully everyone's able to see the screen okay. Appreciate the opportunity to speak with you today. My name is Andy Miller. I work at Pice Energy Solutions, which is a Yokogawa company. My role is in financing corporate development. So Pice Energy Solutions is a software and grid controls company that was really created to solve two fundamental problems that are happening in the power industry. The grid is becoming more renewable and it's becoming more distributed. And as those two fundamental trends proliferate across power grids all over the world, it creates really new grid operating challenges that existing technologies were limited or unable to address. And so Pice Energy Solutions has a platform solution to help enable more renewables to be integrated into power grids and really remove the technical limitations of moving grids to up to 100% renewable energy. And so I'm going to talk about some use cases that we've done where we've actually been able to demonstrate that. So it's very exciting. So before I go into those specific use cases, I'll talk a little bit about our software and controls platform and some of the products. Our software product is a platform solution that combines a number of enabling technologies that has applications across the power grid, from transmission, utility scale applications, controlling large scale solar plus storage or wind plus storage, all the way down to the household in managing thousands of distributed energy resources across distribution networks. So this platform solution is really sold across three core products that we have. We have a power plant control solution, which, as I mentioned, our specific focus is in the more complex control requirements for renewable power generation. So that would be solar storage, wind storage, or solar only with more complex interconnection requirements. We also have our microgrid controller solution, which is a software and control solution used for managing co-located distributed resources to meet a local objective. And that can be both behind the meter at, say, a large campus microgrid, where they're solving for use cases like being able to seamlessly connect and disconnect from the grid when there's power disturbances, as well as economic objectives like solving for demand charge management. And that can also be applied in front of the meter applications as well, deploying microgrids at utility substations to help integrate more renewables and more distributed assets. And then finally, our distributed energy resource management system is a solution that's used to manage thousands to hundreds of thousands of devices across the utilities distribution system. Ultimately, all of these products in combination are what we use to help utilities and grid operators achieve higher levels of integration of renewables and be able to meet their distributed resource management objectives. So next, I'll get into a couple of the use cases to illustrate some of the value that these offerings have, and talk a little bit about some considerations, of course, specifically for this audience as it pertains to solar. First project I'm going to talk about is a project that's in Central California here in the United States. This is a 200 megawatt solar farm that had some very unique requirements that our solution was used to address. So this particular site had 4 separate solar plants, each with their own power purchase agreement and control objectives, as well as all those needed to be managed at a central point of interconnection. And so we deployed our control solution to replace an existing solution, which was challenged to meet the complex interconnection requirements that were required of this solar facility. One of those being able to manage the voltage requirements. So when we deployed our control solution, we were able to address these local objectives for each of those 4 plants, as well as have a hierarchical controller to manage the interconnection requirements at the point of interconnection. And one of the things that's interesting about this particular use case and why I bring it up is that, had this control solution been deployed early in the project and factored into the project's design, we could have eliminated $2 million worth of capacitor banks that were used to address those voltage requirements. This could have been done simply by more intelligent control that's orchestrating the entire site. So you can see here, this is a one-line diagram of this particular solar facility. You have the 4 different power plants, each with their own PPA requirements. Our controller solution could manage each one of these sites to meet the local voltage requirements, as well as address the requirements to interconnect to the grid here in California. The second case I want to get into is an island, Pacific Island, where we deployed our controller solution, which is paired wind as well as battery storage control. And I do recognize that this is a solar conference, but I think this use case really does help apply in the solar case as well, and what can be possible when you really maximize the use of an energy storage asset that's located with a renewable site. So to get into the specifics, this is a fairly large island. It's about a 200 megawatt island, 70,000 customers. It's a fairly high amount of renewable penetration. So they have about 60 megawatts worth of rooftop solar, 70 megawatts worth of wind, and 31 megawatts of battery storage. Our PICE controller was deployed on an existing wind farm that had 24 megawatt wind farm with 11 megawatts worth of storage. The initial use case that we were deployed to address is to manage the ramp control requirements for the wind asset. And so you can see on the left-hand side of this diagram here, what we're doing is managing the available wind and using the battery to shape that to meet a specific requirement. So slowing the rate of change into the power grid so that the system would maintain its stability. And what we were able to demonstrate through our high speed and accurate control was an over 50% improvement in that ramp rate control. So we were able to meet all of the ramping requirements. So that does have some benefit for the power grid, and certainly is important to be able to address. But one of the things that I think is most interesting about this particular use case is when we use that energy storage asset not just to solve a local objective of ramp control, but to actually manage the supply and demand balance of the entire island. And so what you can see here, this island, which has a high amount of renewable energies, is having a hard time keeping the grid in balance. And so you can see that as reflected in the fluctuations of the frequency of the island. Why this matters is if the frequency fluctuates at too low a level, that actually creates power outages. And so right now, the grid has 7 diesel generation units that are all monitoring this frequency variable and constantly moving up and down throughout the day to keep the system in balance. What we did with no new infrastructure, just using more intelligent control on the existing energy storage assets on the island, was to flatline that frequency and basically stabilize it by over 4x what it was prior to us doing that control, so that the diesel generation units could remain parked at their most optimal levels. This is really, really important and illustrated by the fact that we went from having 7 diesel generation units to keep the system balanced to just 1 diesel generation unit used to backfill the battery while all the others could operate as efficiently as possible. And the payback on this particular use case is less than 5 years on just the fuel savings alone. It also, by reducing the number of diesel units that were required to meet this use case, we can enable more renewable integration into the island and reduce the renewable curtailment. In this particular island, they were curtailing the wind assets here at 8 to 10% each year. With a more intelligent control solution and using an energy storage asset, we could essentially eliminate the curtailment of those renewable assets. And so there's a really compelling case of how to use energy storage to help improve the reliability of an island, which has very powerful economic case. The final use case I'll talk about is our application of our distributed energy resource management system. And this is with Horizon Power in Western Australia. So Horizon Power has a pretty unique service territory. So they have a very large geographic footprint. It's actually the size of 2 Texases, but very low population density. And so what that means for them is they have a number of remote communities out in the outback, or microgrids that are not connected to a larger power grid. And those microgrids are running on very expensive diesel generation. So PICE was brought on to deploy our distributed energy resource management system to help coordinate and control up to 50,000 customer DERs, as well as the utility assets. And in addition, deploy our microgrid solution to help manage 11 megawatt renewable-based microgrid. What we're able to demonstrate on this particular application was an ability to increase the hosting capacity of this within this service territory of 4x. So before this control solution was deployed, they had to put moratoriums on the solar and were unable to add more residential solar. By integrating the distributed energy resource management system with our microgrid controller, we are able to remove that technical limitation to allow as much renewables to be integrated into the system. We're also able to demonstrate the ability to run this microgrid at 100% renewable energy. And what's also very unique about this is that it was running 100% on inverter-based resources. There was no spinning generation on that system. And so through the high-speed control, as well as the distributed energy management system, we're able to demonstrate that first in the world capability. And then finally, as illustrated in the previous use case, because we're able to manage these assets more intelligently, we're able to reduce the amount of spinning reserve for this particular system, where they were running 2 diesel generators to keep the system balanced down to 1 diesel generation unit. And that has meaningful impacts in terms of reducing the amount of fuel burned for that microgrid application. And that, I'll end it there. I think we are, keep us on time with the panel discussion.
Now it's time to begin our first panel discussion, which is on large scale solar growth opportunities and technology outlook. And to discuss this, we have in the panel with us Mr. Robert Marlin. He is from Pavi Green Renewable Energy, Mr. Nonthi from Mott McDonald, Mr. Kitty Hat from Tawipong from the Lantau Group, Mr. Millen from Hexagon Peak, and Mr. Andy Miller from Yokogawa Company. Now, I welcome all the panelists on screen and request Mr. Robert to lead the discussion.
Okay, good afternoon. Yeah, maybe Andy, you're still presenting. Maybe, yeah. Okay, great. Now, very interesting presentations from both Non and Andy. Thank you very much, and good afternoon to all those who are viewing us here via social media or other media for the Solar Quarter Thailand Solar Week 2023. So my the first, maybe let's start by giving an opportunity to our panelists this afternoon to give a quick description about themselves, their company, and what's keeping them busy right now. So maybe, well, since Andy and Non already presented, maybe let's give a chance to Kit to say something, give a short background.
Thanks, Robin. Hi, everyone. This is Kit here. I'm from the Lantalk Group. I'm a manager based out of our Bangkok office, and we are a commercial consultant focused on the energy space in Southeast Asia and Asia. So we do a lot of work around ranging from renewables to conventional generation, also helping with regulators and market studies and tariff outlooks. So we do a lot of work there with both investors, developers, distributors, generators. Personally, myself, I do a lot of work in our Thailand and our Philippines coverage, actually. So focusing a lot on these two markets. It's been quite an exciting time right now. So as everyone knows, there's a lot of things going on in the Thai market with the FIT round, as well as constantly something exciting going on in the Philippines. So glad to be here.
Great. Thanks, Kit. Now, Milan, would you like to give a short backgrounder about your company, yourself, and what keeps you busy right now? Hello, Milan. I think Milan still has some problems with his audio. So, anyway, Milan, my friend, anytime that you are ready with your audio, just pitch in, and we'll be glad to hear from you. Now, to get started with the panel discussion, maybe the first question is that in terms of the outlook of the utility scale market in Thailand, um, maybe uh, Kit, would you like to start off the discussion by uh, giving your thoughts about the growth potential of the utility scale market in Thailand and possibly in Southeast Asia?
Thanks, happy to. So in terms of your utility scale market here, I think in Thailand things have been a bit slow for a while. Everyone's been waiting since the last auction round to see what development routes there would be. As we know, the Thai market is still quite centralized, so developers are reliant on a government push. I think more recently there's been more positive developments on the government side. So we have a FIT round that's going on now, which includes 5.2 gigawatts of renewables. And I think overall, in general, there's also a greater push to renewables in Thailand. Now we're looking at close to 7 gigawatts of additional renewables within the end of this decade. So things are looking up. Things are looking much more positive. I think if you look elsewhere in the region, we hear similar things. You see a lot of developments going on in Vietnam. I think people are now waiting on the upcoming PDP, but renewable seems to be a key part of that. In the Philippines, we constantly see developments in terms of large scale solar being looked at and studied. There are a few large solar farms that are also now undergoing development. And there was the recent green energy auction program, which also featured substantial capacities of solar. So quite promising at the moment, I think, for utility scale.
Okay, thanks, Kit. How about our other panelists? Would you like to add anything about the potential of that utility scale solar market in Thailand or in the Southeast Asian region?
I can add a little bit, Robert. I mean, I think the technologies are already there. I mean, as everyone are aware, I mean, the solar PV technologies, not just only the modules, but all the inverters and other aspects are growing really fast. I mean, at a global scale, and that can be technically and practically deployed to Thailand and in Southeast Asia as well. As you can see, we starting to see a number of large scale solar PV projects in many countries. that on the technical perspective, right? I mean, not talking about the commercial considerations, or when we are talking about the growth or any factor accelerating the solar PV market, be the key driver of the solar PV market, either in Thailand or in other countries in Southeast Asia. We have to consider like a collaborations between not just only on the technical side, not just only for the private sector, but need the collaborations with the governmental sectors, how to balance between the the incentive and make sure the benefit to across the sectors, not just only the developers, not just only the governmental sector, but also to the communities as well. And thus sometimes will be the key driver whether to be able to accelerating the market or not. That's from my view. Yeah.
Great, great. How about Andy? Would you like to say something about the potential of utility scale solar?
Yeah, no, I think I agree with both the panelists. I mean, if you look at utility scale solar and just renewables in general, it's unsubsidized, lowest cost production resource. So the economics are really supportive in really all the markets, that we're looking at as well. Some of the stuff that we're seeing in both our primary markets are U.S. and Australia, but we do also have some opportunities in Southeast Asia, is more now looking at the economics of adding storage. And so I know on the utility scale side in the US, there was a big uptick in renewables 5 to 6 years ago. And now all the more recent projects that we're seeing are now adding energy storage. Almost every single RFP that's going out has solar plus storage. And I think that's something I could envision happening in the Southeast Asian markets as well, as there's a lot of value to have storage co-located with some of these utility scale assets.
Yeah,
Yes.
I totally agree with Andy on one point that I mean we will definitely see the combination of not just solar PV alone in the futures, but also together with the other innovatives or other technologies like Andy mentioned, like co-located with the either wind projects or the easiest ways to collocate. I mean, how introducing the energy storage system integrating with the solar PV plants, because I mean, every countries would like to introduce more of the renewable energies, and on one hand, you can improve the existing grid and transmission. I mean, capability to handle the renewable energies, right? But on the easier way you can like use the benefit of energy storage system to matching balancing between the generations and demand as well. And that is something we will definitely see in Asia. I mean, first of the countries in Asia that use the energy storage integrate with solar will be around in northern Asia, like in Japan. We're starting to see quite a large scale solar hybrid with energy storage in the Philippines. You can see the recently announced free-in tariff in Thailand, allowing opening the room for the developers to consider the solar plus energy storage system as well. Even though the feed-in tariff is not, again, really depends on the developer's view, right? But I mean, the rate is still challenging as well to be competitive, right? I mean, 2.8, I think if I remember correctly, like 2.8 baht per kilowatt hour for the hybrid system, comparing with 2.1 baht for standalone solar PV plant. Yeah.
How much again? None. The feed-in tariff rate
Um,
for solar with storage.
yes, 2.8 baht, which is equal to around sorry, I have to quick calculate. Two
2.8.
2.8 baht, Thai baht.
2.8.
Yeah, yeah, 2.8.
Compared to solar only of 2.5, right?
2.1, 2.1, 2.1.
2.1.
Yeah.
Oh,
So
interesting.
around 7.7 or 7.8 cent US cent per kilowatt hour for the solar with energy storage system. Yeah,
Okay,
around that.
great. And do you think at those price points, non, Do you think that it's attractive for developers to invest in
Well,
solar plus storage?
on one way, even though, for example, even though it is not attractive, but the developers keen to jump to consider those options, because by the regulatory, I mean, the authority will prioritize solar with hybrid applications before considering the standalone solar, and that will be the key driver that the developers will try to optimize, not on the technical but on the economics, to make the projects feasible anyway. Yeah.
Okay, thank you, Non. By the way, Kit, do you have any thoughts? Because solar with storage, I mean, from a generation perspective, I think Non gave a very good insights about it. But from a grid stability standpoint, can you say anything about that part of a use case for storage?
Yeah, happy to. So on that point with battery, I think as everyone's well aware, the battery system really helps to improve the, I guess, helps to shave off that solar production so that you get more of a base load mid-merit generation profile.
Mm-hmm.
And it's just a profile that is a lot easier to integrate into the existing grid. With that said, though, one of the positives and advantages of the Thai grid is that there is quite a lot of flexible generation in the Thai grid already because of its historical reliance on gas. So battery storage will help, create a solar hybrid project that can have a base load generation, but the Thai grid itself also has the flexibility that can help to mitigate any potential variability in solar. I
Okay.
think that there were some views earlier from a generation point of view, but from a distribution and a retailing point of view, most of those players also much favor a hybrid system. It's much easier for them to manage. Some of the not so in Thailand, as non mentioned, we have the fit round, which includes a solar hybrid category, and I think he also mentioned earlier that we're seeing some solar hybrid projects in the Philippines. I think there, rather than a government body mandating a hybrid project, there was actually a commercial development between a distributor, Morocco, who wanted a type of baseload renewable solution. So it's quite positive to see that as well.
Yeah, it's very interesting that the news about that Meralco base RE baseload bid reached all the way to Thailand. Now, guys, any of you, what were your thoughts? I mean, uh, Andy, Kit, Non, does RE baseload using solar with energy storage, does it really make sense at a price point of what, say, uh, it's in 6 pesos. I don't know the conversion to Thai baht or US dollars, but at that price point, does it really, based on your expert opinion, what are your thoughts? RE base load.
Yeah, actually, I
And
missed the part of the question on my end. I don't know if that was just me, but
Well, Andy, the question is, well, Non and Kit, they mentioned that solar and battery is will really drive the solar utility sector. And they even mentioned that about an interesting um, uh, bid here in the Philippines, with Meralco signing up a developer for an RE base load, a solar with storage base load 24 by 7.
yeah,
Okay, yeah, at a price point which is really low, at maybe six pesos. Okay.
I think that's the
Um,
equivalent of around 3.7 baht per kilowatt hour.
yep, yep. What are your thoughts on that? If you were the developer, do you think you will make you will make decent profit from at that price point?
I mean, I'll let the others comment. I think to me, renewables and storage are the lowest hanging fruit, probably the highest, most you suitable application right now isn't necessarily for baseload. There are certainly applications, and if that is the if there's an economic case for it. I think with storage managing the peaks, so increasing the utilization on the asset. So there's certain periods where the storage has a pretty high economic return. So those shorter duration type applications, I think, have really good economics. But certainly on the base load side, there's a lot of longer duration storage technologies that are out there. And the economics on those are getting a lot better than they were a few years ago. So definitely have seen certain cases where that can be competitive with other generation.
How about Kit? Non, your thoughts on RE baseload?
Maybe some, I guess, initial thoughts. I think RE base load is probably the way the market is going to start to pivot into as we get more and more RE into the system. It's just the next natural um, evolution for it. In terms of the price points, I can't comment too much on that project specifically without knowing the details. But I think generally speaking, recently developers have been coming under a lot more pressure from a cost point of view because costs for PV systems and development over the past 6 to 12 months have escalated substantially, right? Due to the ongoing Russia-Ukraine war, the global economic situation. I think currency risk has also involved in this part of the world versus the US dollar.
Mm.
There's been quite a lot of movements there as well that made projects that looked attractive, say 6 months ago, now you have to look much closer at them today.
Mm. And add to Kun Kititat as well, like due to the supply chains situation now and the high demand in the solar PV, and not just solar PV but also on the energy storage side as well. So if you ask me, like 1 year back, 2 years back, we would expect the price of solar PV modules and energy storage system to gradually decreases, right, due to the more maturity in the technology itself and the competitiveness of the solar PV business. But it turns out to be now, if you ask as of today, the price isn't that cheaper by now. In contrast, it somehow slightly increases as well, and even the suppliers sometimes have to adjust the price to be higher. And this is not just only for the solar modules, but the same for the energy storage system as well. Yeah.
Now, just one last item about energy storage. I mean, there are different technologies of energy storage, and we all know that there's a current supply situation for lithium ion battery energy storage. Can you give your thoughts about other alternatives? I think the flywheels and the supercapacitors are gaining headway and are very aggressive in trying to find their niche and their place in the market share with regards to energy storage. Your thoughts on this? Maybe we can start with Andy.
Yeah, one of the companies that we work with, and I think one of the pretty promising technologies around flow battery technologies, which work really well for longer duration, 4 hour plus type applications. So we work with a company called ESS, based out of the Western United States, and they have been aggressively growing their capacity. We've deployed a couple projects with them. So those technologies in terms of flow batteries, I think, is really a big game changer in making lithium ion has really been the leader and is very for the shorter duration use cases in particular, in fast responding use cases, it makes a lot of sense and it still is the leader. But I do think flow technologies are really close behind it, and I think to me are probably the most promising of the technologies.
How about non? Kit, any any inputs on that?
I think the same view as Andy. I think that explains well the current and near future situations that there will be another technologies becoming to be um, taking place and sounds promising rather than the lithium ion. Yeah,
Kit, you have
Yeah, nothing to add from your side. I think
uh,
Andy have non have covered it quite well.
okay, great. Now, um, so more than the batteries, I think let's go back to the solar utility scale side. Land is it's a finite resource. You know, at some point in time, we might run out of space for ground mount utility scale solar. What are your thoughts on floating solar, and what do you think is the trajectory or growth trajectory in terms of from a price point standpoint and from an development standpoint? Do you think floating solar will really be something to really look at from a developer's perspective? Maybe Non, you'd like to give your thoughts on this?
sure, Robert. When we talk about the floating solar, there are certain benefits that will be the main factors convincing the developers to explore. We are talking about the potentially better performance comparing with the ground mount, mainly due to the possible cooling effect from the water to to reduce the temperature loss experienced by the PV modules. We are talking about like the floating solar, as you mentioned, is showing the smart way to maximize the land utilizations, especially for the regions with the issues on the land availability. Like, but again, this might not be the case for Thailand now. Maybe in the futures, but in some other countries like in Japan, Iran area, it's very expensive, and therefore that might be a promising alternative solutions. We also talk about um, in terms of the price point on the floating solar PV. If you look into the news just recently, in some of the floating solar PV in some regions, the price tends to be pretty much closer or sometimes equivalent to the ground mount solar PV projects. But again, that's quite project specific aspects. But in terms of the price, is is becoming cheaper as well for the floating solar PV. Now, I think the point is that the only key concerns or the key challenge on the floating is that is lack of the long term proven track record. We haven't witnessed the long term floating solar PV projects in operations, right? When comparing with the ground mount projects that we have seen, the projects operating for over 10 years now, and is still operating well. This this will be the case for floating. I believe, but it's a matter of the level of comfort or confidence by sometimes by the investor or sometimes by the financiers, and that will become the questions of how the financiers or the developers be comfort with the floating solar large scale or utility scale floating solar PV projects. That will be the point that will take some time, and based on my personal experience, the concerns will be around the how we can prove the reliability, the long-term durability of the floating system, considering the fact that we are placing the module, we are placing the system over the water, and it will be affected by multiple loads at the same time. Sometimes it's dynamic load, right? The load from the wave, the load from the wind, and how can we assure the long-term um, um, durability, reliability of the designs of the system that 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 will be one of the interesting area. Yeah.
Yeah. How about Kit? Any thoughts about floating solar?
I think it's definitely something that's coming up more and more now. I think in Thailand, EGAT has been deploying quite a bit of floating solar of their hydroelectric dams. So the floating solar is supposed to hybridize and with the hydro generation to create something that's less spiky in terms of your generation profile. I think the first few projects have been quite positive, so they're now deploying more of those and accelerating their plans. Elsewhere in Thailand, you also get floating solar projects in catchment areas, in industrial parks as well. So definitely something that's becoming more common.
Okay, thanks. And how about Andy? You have any thoughts about the future of floating solar?
I mean, I think it's really promising, and I know though there's a lot of the applications we'll look at are in islands, right, where one of the primary limitations is not economics, and the use case that we bring to the table is help move some of those technical limitations, but space is a really important consideration to move them towards 100% renewable energy. There are certain limitations. So I still think there's a lot of low hanging fruit in terms of being able to deploy solar within some of the existing land based locations where the economics are better. But eventually, I do see a big opportunity for floating solar. Once the economics make more sense.
Okay, Andy, maybe on to the next question. I'd like to start with you. What do you think are the main challenges? Are there any challenges with regards to interconnection in Thailand or in anywhere in Southeast Asia? And how about controls? Does the controls like the product that that you have,
Mhm.
does it play a role in mitigating these challenges in that the developers are facing right now?
Yeah, I think particularly, when we are talking about the interconnection challenges, I go back to the grid operators and the challenges they're facing. So as you add more renewables and your grid becomes more distributed, that that equation becomes more complex and more challenging for those operators. And so the way that they're going to use to manage that is to put more stringent interconnection requirements. So that's what we see in areas like places where we operate in California, which is a high amount of renewable penetration. So they're starting to hit some of these limitations where they're putting stricter requirements on the developers on these renewable sites to be able to manage the power that's going in. So I think having an appropriate control solution to be able to meet those complex requirements, generally speaking, you're going to have that paired restored so that you can shape some of the solar or wind assets so that you can do that. I think that's a really important consideration. I think the other part is to look at on the other end of the equation is how do we enable those operators to be able to kind of unlock or allow more renewables into their systems. And so having a control solution within those utility systems that can soften some of those requirements or remove some of those limitations, I think is something that we're looking at. I think it's really important as well. And controls, software and controls is a key part of that equation.
Okay, thanks, Andy. How about other challenges? Kit, can you think of other challenges that are being experienced in Thailand or anywhere in Southeast Asia?
Sure. Thanks for the question. I think in Thailand, one of the key challenges for developers is really lack of a clear route to market. I think if you look at renewables development, a lot of the developers that are positioning for the upcoming FIT round, they've been waiting. So the last wind round was 7 years ago, and then the last solar round was back in, I think it was early, might have been 2008, 2009. So it's been a long time coming since large scale renewable options were available in Thailand. It's still a monopolized market, even though we think commercially it makes a lot of sense. I think especially in Thailand, there's been a high reliance on LNG, and prices have increased substantially due to the Russia-Ukraine war. So we're finding that large-scale renewables and solar could actually come in to help reduce tariff pressure. So commercially, it makes a lot of sense, but from a regulatory standpoint, they can't commercialize projects because they're not able to sell to an end user. They have to wait for a government mandated auction where they can sell to EGAT, and that doesn't come around very often.
Okay. How about Non? Any thoughts about what are the risks,
Sure.
challenges in Thailand?
Sure. I think continuing from Kun Giti touch on the pressure on the feed-in tariff, I mean that's become clear that if we are comparing with the last 9 or 10 years, where in Thailand developers enjoyed really high premium on the adder, like 8 baht, 8 Thai baht, which is around I think um, almost 4 times higher than the current feed-in tariff that gonna receive for this round of the scheme, right? And in the past, the design of the solar PV projects can be designed in the way to maximize the energy productions, right? I mean, and the designer may not have to worry much on the technical perspective, because at the end, I mean, the developers still enjoy the feed-in tariff. But that may not be the case for now on and onwards, where the feed-in tariff is very is lower than in the past, and therefore the design philosophy, the plant configurations, the technologies to be selected and deployed to the projects have to be carefully thought, and we have to run it like a number of scenarios of techno-economics optimization, try to find the way to optimize the design, which try with the aim to lowest the levelized cost of electricity as much as possible, trying to squeeze the performance of the projects as much as possible. One of the example, just for example, like in the past in Thailand, you may experience the solar PV developed in the way to have the space between the modules of between the PV arrays of over 1 meter, maybe sometimes over 2 meters, to avoid the shading impacts, right? I mean, but now on, given the land availability limits, given the low feed-in tariff, so the designer may have to decide the plants in the way to maybe need to shorter the internal spacings, may need to adjust the tilt angle, try to find the balance between the increase in elevation gain and the lower the shading impacts in the same time. So there will be much more aspects to consider given the pressures on the feed-in tariff. Yeah, that's from the technical standpoint.
Okay, great, great. Thanks, Non. Now, with regards to inverter technology, I believe that the inverter is the heart of every solar system. So I've maybe 6, 7, maybe 8 years ago, central inverters were the thing, right? But now I think string inverters are becoming more widely used globally. What are your thoughts between using central versus string inverters? Maybe we can start with Andy.
Yeah, I think there's a couple considerations when you think about inverters. Certainly, there's some redundancy, reliability considerations that need to be made when you're thinking about central versus string inverters, and sort of looking at the risk and the cost benefits of that. Another thing, just with respect to inverters, that we pay a lot of attention to is depending on your use case, how fast are they able to respond? I think that starts to become particularly important as well. But I think there's many considerations when you're making those design decisions. When you pick between central versus string inverter, I think more and more we've definitely seen string inverters be more popular, and I think that certainly has a lot to do, I think, with the fact that it gives you a little additional redundancy, removes single points of failure.
Okay, thanks, Andy. How about Kit? What do you think? Central or string?
Thanks, Robin. On this, I'm probably less attuned to what's going on in the inverter space. So I'll probably leave it to Andy and Non to comment on this topic.
Okay, thanks, Kit. How about Non? Your
Sure,
thoughts?
Robert. First of all, I think that there is no right or wrong answers to these questions. I believe it really depends on two factors in the the price, right? I will not comment on the price because this solely depends on the strategy of the developers, right? I mean, what I can comment is on the technologies or technical perspective. We have seen quite a number of developers now try, especially for the large scale projects. They tend to sometimes introduce both central and string inverter into the same plants, and especially if that projects, when we talk about the large scale solar PV plant, let's say over 100 megawatt scale, the project has to be developed over a single land parcels, and many times it's difficult to find the entirely flat land area to develop projects, and sometimes part of the projects may have to be installed on the complex topography. And at that situation, when the modules are located pressing over the complex topography, the orientations, the tilt angle will not be as the design, right? It will be deviate depends on the ground slope. And that's come to the point of some some additional benefit if considering string inverter, because string inverter we are talking about is inverters controlling the smaller set of the PV modules, and therefore some developers even for us as well as technical advisor, we see the benefit of at that situations, um, having modules install over different orientations into the same string, into the same inverters. We will experience or we can expect what we call the mismatch either in current or in voltage. And for central inverter typically it's come with minimum numbers of the MPPT, which is the algorithm to track the power of the PV arrays. And if you can imagine using the string inverter, one string inverter will control smaller set of the PV modules. And if we carefully design the plant, we can design the plant in the way that modules are renting into the same directions, interconnect into one string inverters. And with that approach, we will minimize the impacts of mismatch loss due to the multiple orientations of the PV modules. And that is somehow to be one of the advantage of the string inverters. Given its smaller size, it can be deployed to multiple areas of the projects and its control smaller scale of the PV modules. That is one of the key benefits. Some developers also say like having developing the projects over really hilly area, they sometimes see the benefit of string inverter in the way of easier for them to transport, move around during the operation as well. That is some of the side benefit, I would say. But again, of course, at the end, these factors might be outweighed by the price of inverters or the strategy of the each developers when developing the projects. Yeah.
Yeah, great, great answer, gentlemen. Great answers. Now, last but not the least, of course, we have to talk about the solar panels and the technology projection of the solar panels. Um, what can you say about the new technologies that are emerging in the market, particularly the N-type, the HJT solar panels, from a price point, from an LCOE perspective? Um, what are your thoughts on these? Andy, would you like to start?
Actually, I think in terms of panels, I may defer to some of the other panelists on that. We we tend to track inverters, some of those technologies, and are paying attention to LCOEs, but not as um, I don't have as much of a detailed understanding on the panel technologies.
Okay. How about Kit?
Yeah, actually, from RM, we also do a lot of tracking on an LCOE all-in cost. We track less so on each component, though I guess more general comment that I could say was, again, prior to, I think last year, we had seen costs generally coming down. And in general, seems like there are new ways to increase efficiency with new technology, but probably not much more in that right now.
None? Anything to say about solar panels?
Um, yeah, I mean, just a quick wrap on this. Um, the solar modules market or the panel markets in terms of the development is growing too fast. I mean, very fast. We were talking about the PRC perks technologies over the last few years, which is the technologies that we can expect high efficiency. But on the other hand, we also found that with the perks technologies, sometimes we might expect some disadvantage of the LETID loss, which is the additional loss s- specifically when using the perks technologies, and the real cost of this loss is not 100% clear, and that is something that I mean we have to consider as well. But again, given the price, given the efficiency standpoint, perks technologies becoming the current normal PV panels that most majority of the developers tends to focus at. And perks technologies is not coming just a standalone monofacial PV modules. Is coming together with the bifacial PV modules, where the bifacial modules means the modules can generate electricity at the rear sides of the PV panels, and the price of the bifacial modules becoming starting to be competitive comparing with the monofacial modules, as I mentioned earlier. We also talk about like a half cut PV modules technologies, which is also already deployed in the commercial scale. The half cut PV module means um, the partial share of the PV modules, only half of the PV modules will be affected, whereas the another half can still generate electricity, which is the benefit of the half cut PV technologies. Um, as I mentioned a little bit in the presentations on the top con technologies, the thermal oxide passive contact technologies. This is the new N-type technologies which has been researched for I think many years, since I think 2014, but just commercially launched. Let's say last 2 years, and it's becoming the new technologies that everyone, it not just only the developers but also on the manufacturers and suppliers will will tend to focus and move forward from the perks to these top cons technologies. So what is top cons technologies? I think in the simple statement, in a simple way as well, um, these modules will introduce one additional layers to the PV modules, which aim to increase the density of power output per one cell, which means that you can expect higher efficiency from the top con technologies comparing with the perks. For the perks, for example, the efficiency might be around, I don't know, maybe around 25%, but for the top con technology, it can be up to around 29 up to 30%. Of course, that at the moment, the price point still be higher than the perks technologies, but those mainly due to the manufacturing process. But of course, that one is coming to the commercial streamlines next year. We would expect the top cons modules to be the price to be more competitive and will becomes to be the new trends of the PV modules. Yeah. And oh yes, because it is N type for the top cons, we we have no worry about the LETID loss, which is the loss we experience in the perks. So this loss will be eliminated, and some of the other loss is expected to be lower than the perks technologies as well, like light induced degradation or LAD. We would expect the LAD loss to be significantly low for these top con technologies. Yeah.
Great. Thank you. Thank you very much. Thank you, Non. Now, I think we've come to a point in this panel wherein we can entertain questions from our audience. Minakshi, are there any questions from? Do we have any questions from the audience?
We don't have any questions at the moment from the audience, so maybe we could take concluding remarks from all our panelists.
Okay. Um, yeah. Any last advice? Any to our audience, to the developers that are listening to us right now, regarding technology and the prospects of renewable energy development, not just in Thailand but in Southeast Asia. Maybe we can start with Andy.
Yeah, obviously, as I've alluded to a lot in my comments, I think when developing these projects and in the design phase, it's really important to consider the controller technology that's going to be managing these assets. And there's a lot of opportunities where you can do some value engineering and incorporating the controller in your design early on. We've seen a lot of projects and deployed on a lot of projects where that decision was made later, and there was some economies that we could have delivered with our solution earlier on in the process. And so I think it's important to think about that when you're designing your plant. And there's definitely a meaningful amount that you can do when that's taken into consideration.
Okay. Kit, any advice for our audience?
Yeah, I think probably just a few final comments from me regarding the outlook. I think quite positive in terms of where renewables is heading, where solar is heading across the region. We're growing into a world where people are not building renewables and solar based on government push policies or incentive mechanisms, but we're also seeing them see it from a cost point of view, from its own merit, that it can provide low cost electricity to the grid. And we're also at low enough, I guess, renewables is coming in from such a small base at the moment where the market can take quite a bit more before we start to see larger issues. So I think it's quite positive outlook for renewables over the next few years.
Great. How about Non?
Sure. I mean, my final thought gonna be like Thailand is one of the countries that renewable energies, especially for the solar, will be further growth following the global trends. That is, of course, is something for sure. The key strength of the Thailand I would like to highlight is that the solar PV projects have been deployed for over decades now, where all the parties, the developers, investors, the financiers, even the governmental sectors are becoming more familiar with the technical, commercial, and contractual challenges. We see like the acceleration of the solar business in Thailand from now on will not further rely on the standalone or conventional ground mount solar PV projects anymore, but will inevitably need the collaborations with the other innovative solutions like the floating solar PV, other options of the hybrid with the energy storage system, co-located with the hydropower plant, or co-located with the wind projects. Those are the themes that we expect to see in the near futures. And I mean, the last point is that I mean the acceleration and the growth of the solar PV market in Thailand will need the collaborations among the sectors. I mean, the markets cannot be driven by just one sector, by just private sector, but also from the relevant authorities, from the governmental sector to ensure like the sustainable growth in long term of the solar PV business in Thailand. Yeah, that's from me.
Okay, thanks, Non. And maybe from my end, I would like to thank uh, Solar Quarter, uh, Minakshi, and all the guys there for this opportunity to be moderator for this afternoon. Maybe my last words for our audience this afternoon is that it's really important to consider the technology when during the design phase, the controls, the panels, the inverters, how we are really going to set up the plant will definitely play a part in reducing our overall cost and protecting our margins. It's also an important to consider that coordination with government, the support of government will really play a huge role in the success of propagating or advancing the adoption of renewable energy, not just solar, regardless of the country, whether it be Thailand or the Philippines or anywhere in Southeast Asia. And again, right, good luck to all of us. I know there are challenges, but I think each nation right now globally is really seriously considering renewable energy as the way of the future. So again, it's exciting things are ahead of us. So thank you and good afternoon. I turn you over now back to Minakshi.
Thank you very much to all our attendees, and thank you to our sponsors for extending their time and support for this event. See you tomorrow for another exciting session based on rooftop solar. Thank you, everyone.